Hey y'all, welcome to another week of Linux stuff. This week we get to deal with file permissions. Yay! I know this is the thing that everybody was absolutely waiting for. It's your favorite topic. I know this. So, let's just dive right in. So, permissions, right? You've seen this before. You've seen it in Windows before. You right click on the file, you hit properties, you go to security, and you can see who all has permissions to the file. I mean, you'll see things like administrator in that window, and they'll have full control, and you'll see other users in there, and they will have less than full control a lot of times. But they can have full control too. The idea with Linux permissions, though, is that they can be that complex. They can be. You typically have to use something called an access control list. If you're in Cisco, that might trigger you a little bit. I'm sorry. Different kind of access control list. It's put together different, but I guess the rules are kind of the same. Where the whole point of it is that you want certain people accessing and certain people not. But Linux permissions in general are less complex than that right off the bat. So we don't really have to worry too much about individual users outside of whoever owns the file. So yeah, the permissions are much more broad, at least right out of the gate. And we're not going to touch ACLs this time anyway, so we can just focus on the basics. The basics look difficult. And at least for the first little bit, as you start to kind of absorb this information, it kind of is. But when you break it down, there isn't too much there. It turns out to be pretty simple. It just looks terrible. Okay, what am I talking about? This over here. See all that gibberish? DRWX R-X R-X number user number. Yeah, right. Okay. So this bit, these are the permissions. This tells you how those permissions are applied. And that's really all you need to know for permission's sake. All right. So what does it mean? So I've got it highlighted in colors for you, so it makes it a little easier. The yellow's not there. I can show you some yellow here in a minute. But let's look at the D. Stands for directory. So if you look right there, you'll see a D. And if you go over, we've talked about the colors before, and that blue color, at least in this screenshot, means a directory. So, right, D, directory. Look over here. There is no D, and it's obviously not a directory. It's a tar.gz. We made some of those before. It's a compressed file, so it's just a file. And yeah, I mean, well, the rest of that stuff is directories. I mean, we can come in here and look at the same stuff. Here, let's do this. So you can see there are many more files in here than there are. Well, it's about even, I guess. This mouse right here. So file, green stuff. Get that out of here. Yeah, so no D is a file. It's a zip file. This is a script or a shell file. Directory, file, directory, file, file. Right? That's the idea. Now, in that spot that we've been looking at, you can also have, well, the first thing is, if there's nothing, it's a file. A dash means nothing, and that just means it's a file. There's no special to it. A B stands for block device. And block devices are like SD cards, hard drives, flash drives, anything that can store other things. That is a block device. C is a character device. You'll see that like TTY1. Let's see if I can. Yeah. So you can see stuff like TTY. And that's really what that is. Those are anything that can accept text. And as you log in, if you're logging into a situation like I'm at right here, you'll notice that those are TTYs, and it stands for teletype. Don't worry too much about it. Just assume it's a terminal, and that's what that really means. And then if you're opening up a terminal in the GUI, it is a pseudo terminal. So a lot of times you'll see that with an S or something like that. Symbolic terminal. Anyway, and L stands for links. So we made links last week or the week before. We've made links before, the soft links, the hard links, that thing. If your file is a link, then it's got an L instead of a C or a D or a dash in this very first column. So that right there might give you some inclination as to why the permissions are the way that they are. But it doesn't really affect the permissions themselves. It's more just file identification. So that first thing, we can throw it out. I mean, we don't really have to think about it too terribly much. It does help us in some certain situations. We're going to talk about some funky things once we get to UMask about directories and how they are different than files, how they'll have different permissions than files. But by and large, there's really not a whole lot to be done with that very first character. So we can safely ignore it about 90% of the time. So that brings us to the blue color, which is the next color here. So look right here. You can see RWX. Now, it's the first time we've seen RWX, or at least the first time we've tried to explain RWX. So what does it mean? R stands for read, W stands for write, and X stands for execute. That's simple enough, right? Read. Can you look at the contents of the file? Right? Write. Can you add or subtract something from the contents of the file? X. Can you run the file? You won't have X on a lot of stuff. I mean, regular files don't need X. You don't need X to be able to launch a JPEG. You don't need X to be able to watch a video. You don't need X to be able to do just about anything. So anything other than run an executable file. If your file is not executable in, AVI files, MP4 files, MKV files, JPEG files, PNG files, any of that stuff, none of that stuff is executable. So you don't really need X for pretty much anything. So read and write are really the only main permissions that you're going to be dealing with on a regular basis. And it really is that simple. So what's hard is like looking at these things, realizing there are columns and realizing there are things that only some of those letters pertain to, right? So those first three letters pertain to this column. This column represents the owner of the file or owner of the directory or owner of whatever is right here. This is the person that owns it. They likely created it, or they took ownership of it because they have permissions. And basically what that means is, if you want to do anything like delete it, a lot of times you're going to have to ask permission of the owner. So the owner, which pertains to this column of permissions right here, the stuff highlighted in blue, those are the biggest set of permissions, the most important set of permissions. The second column means the same thing overall as far as what you can do to the file, but it's talking about different people. So I know how that looks because this is the column, but give me a sec. We're going to look over here for that. So look at the purple though. It's not quite the same as RWX. R nothing X. So what does that mean? So this file, you could read, write, and execute it. This file, you can read and execute it. That's it. No write. That dash means nothing, which means we don't get the write attribute on that particular file as it pertains to the group ownership. So I know how this looks. You've got Leo on the left-hand side, that's the user owner, and you've got Leo on the right-hand side, that's the group owner. Well, take a step back real quick, because we haven't really dove into users and groups just yet. But suffice it to say that every time you create a user, an identical group identification is created. And when you want nobody else to be messing with your files, you want to both own them and group own them. But we could easily go in here and say, let's say we had Betty as a secondary user. I could add Betty over here. Or I could change this to be Betty. So that Betty could have read and execute access, or read, write, and execute access on this particular folder read, write, and execute on this particular folder. So if you look over here, we kind of have that situation where root is the owner of these files, and I mean, as it should be. You don't want users to be able to do much of anything with them, maybe just look at them or something like that. And dial out. So dial out is basically a nomenclature from whenever we used to be able to remote into Linux terminals from a modem, and you would get one of these. So this would allow tons and tons of people to log into the Linux terminal and use it all at the same time. And you would start with S0. First person to dial in would get S0. Second person would get S1. And you would need to be added to the dial out group to be able to do this. Right? So you would go in and, I won't show you the command because I'm not trying to confuse you, but you would go in and basically add Leo to the dial out group, and now Leo can log in, and dial out on this particular terminal gets read and write. So somebody on the read and write group can dial in to the Linux box, and they would get the ability to change up stuff inside of the terminal, inside of their terminal. So the idea, though, is that this first column affects the owner of the file. The second column affects anybody in this group. As a matter of fact, I can add people to the Leo group too. So you can do that. You can add Betty to the Leo group. That way you don't have to really change permissions on the file, but Betty would still get these permissions, these middle column of permissions. And now this last set, there is no third column here. This last set is everybody else. If you are on the system at all, if you have a username, if you've logged into the system, these are the permissions that pertain to you. So that means that everybody on the system can read these files and execute them. In this case, directory has a different meaning for execute. We'll get to that, though. So read and execute, 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 blah, 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 right? And then, if you look over here to these terminals, people that aren't root, right, because the owner, and that aren't in the dial out group that would get read write, get nothing. You get nothing, and you will like it. So if you are not root and you are not in the dial out group, you get nothing. That's how you read these permissions, right? From left, this column corresponds to this column. This column corresponds to this column. And this column corresponds to everybody else, and in this case, nothing. But in the case over here in the notes, you've got read and execute and read. So the hardest part about these permissions is understanding what pertains to what, and that's how you do it. There are 3 columns that can have read, write, and execute, read, write, and execute, read, write, and execute. And each read, write, and execute pertains to user owner, group owner, everybody else, or you'll see it as other. So that's the deal. Those are the basics of permissions, and that's really as far as we're going to go. You can add a couple of different special permissions. We'll talk about those, but I'm not going to ask you to do anything outside of just look at those columns, compare them to the users and groups, and make a determination as to what kind of permissions we're dealing with. That's pretty much it. Okay. So what we need to do now, though, is change them. So making a determination, right? This is the idea with that. You make a determination that this particular directory has too many or too little permissions on it, so we need to make a change to it. So here's the idea with that. So we said RWX are the only things that could show up in these permissions. So how do you change them? How do you add read or subtract write or add execute or just zero out all of the permissions? Well, let's create ourselves a couple of files to play with. So actually we have some files. So let's just play with these. All right. So you have these. Permissions are actually created out of an octal mode, and that sounds weird. It's if if you've talked about the numbering systems that we have in computing, we have binary, we have octal, we have decimal, which is more a human thing, and then we have hexadecimal, right? So octal is what we're concentrating here, because before hex really came out, we had a lot of octal. Octal basically counts from 0 to 7 and then starts over, right? So after you hit 7, you go to 10, 11, 12, 13, 14. Once you get to 17, you come down to 20, right? But I don't need you to know how to count in octal. I need you to know how to count to 7. That's it. If you can count to 7, you can handle these permissions. I know you can all count to 7, right? So here's the deal. Read, think of it kind of on a point system. Read is worth 4 points. W is worth 2 points. X is worth 1 point. And nothing is worth no points. So let's say that we wanted, for example, read write. And so let's just focus on one column. It doesn't matter which column because they'll all be referenced as the same octal mode, no matter if you're working with the user owner, group owner, or other. So let's just focus on this. Let's pretend, it doesn't even matter. This could be group, could be user, it could be other. Does not matter. Read write. How would you calculate that? Right? How would I know what number I need to use if I want to say I want this particular file to have read write in this spot? All you got to do is find out how much read is worth, 4. Find out how much write is worth, 2, and add them together. Right? Because dash is worth 0, so there's nothing to add there. You get 4 plus 2, and that equals 6. Right? So to get read write, you just need to know 6. 4 plus 2. Read plus write. That's it. And you get 6. But when you're dealing with octal modes, you have to affect all of the permissions at the same time. So you have to kind of take a step back and see what the rest of the permissions are, or what they need to be, and do a quick calculation on that. So let's say we want the group owner to only have read. Well, that math is super easy, right? Let's do this. So read, we don't want write or execute on that. That is 4 plus nothing, right? That's it. So 4 plus nothing is 4. And let's say for others, we don't want them to have any permissions at all. Well, there's nothing to add there. So now let's look at the sums of each of those, 6 and 4 and 0. So what do those permissions actually come out to? What do they look like? Once you apply them, what do they look like? This right here. Right? Notice 640. 640. The only real math you needed to do was read is 4, write is 2, 6. That's it. Now, the reason I said I needed you to be able to count to 7 is because the maximum permission that you can give anything is read, write, and execute. So 4 plus 2 plus 1 is 7. That's it. I said we were going to do the basics of permissions. This is the basics of permissions. So as long as you can count to 7, as long as you can remember these 3 facts, well, 4, I guess. R is 4, W is 2, X is 1. Those don't change. They're not sneaky. Like read is not just sometimes 3 or sometimes 5, and write is never 0, right? Like those are the answers. Read is 4, write is 2, X is 1. Execute. When you add them all together, you want to give everybody all the permissions. You would say this, right? User owner has read write X, group owner has read write X, and everybody else has read write execute. And if you do the math on that, 7 RWX, 4 and 2 and 1 is 7, 4 and 2 and 1 is 7, 4 and 2 and 1 is 7. So those are your permissions, 7, 7, 7. Here's a hint, though. If you're ever adding 777 to a file, you've probably done something wrong, or you're extremely frustrated and don't know why permissions are breaking things. 777 should only ever be used as a test, and then you configure the permissions properly. You will, I guarantee it. When you're in Linux and there's going to be someone telling you how to set something up or whatever, and they're like, permission 777, there should be a little alarm in your head going off, being like, this guy doesn't know what he's talking about, or this is going to change in a couple of steps. And if it never changes by the end of that thing, yeah, something went wrong. Yeah, there's some miscalculation in what needs to happen there. It is exceedingly rare to ever see this, 777, on any given file. Because that means that anybody on the entire system could delete it, right? They have the right permission. They have the yeah. So typically you'll have something like this, right? So if you do want to give if you do want to give full permission to, say, the user owner and the group owner, you can do that, right? Like user owner has read write X, they can do whatever they want. Group owner has read write X, they can do whatever they want. But everybody else only has read, so they can see the file, they can maybe copy the file or something like that. But to the original file, they can't do anything. They can't change anything on that file. And more commonly, you're going to see this, where others on the system have no permission whatsoever on the file. But group owner, user owner do. And this is an exceedingly more popular permission set, where the owner can do whatever they, usually can do whatever they want, and then the group can see stuff, right? Because people aren't just part of groups, they have to get added somehow. So this adds a semblance of security, and then everybody else, right? So that was the group right here. Everybody else can do nothing. They can't read it, they can't write to it, they can't execute it, they can't do anything. Absolutely nothing to it. Okay. Now, we've talked a little bit about permissions, about what they represent, but you'll never really see them written like this. You'll only see them written like this. This is so we can manipulate them. This is so we can figure out what we're dealing with on a particular file. So here's the deal. What if we want to change them? You already know the steps. You've already gotten an idea of how to do this. So first thing you got to know is the command to do so, and that is change mode. So as I mentioned, these are octal modes. Yep, right here. And the command rebuffs that, right? Change mode. It's an abbreviation, obviously. So let's change the modes on this file, on a file. So let's take this hello file, for instance. It's got read, write, read on it, right? So read, write, that first column. This is user owner, group owner, everybody else. So let's tinker with it. So real quick, you got to figure out what's here already. Read, write, right? What was read? Read is 4, write is 2. Read, write, that's 6. Read, write again, that's 6. Read by itself, that's 4. So 6, 6, 4. So what if I wanted to change that? What if I wanted to, let's say we want to make just one simple change. We want to give the others group, you know what? Let's just do, oh, no, that's fine. Let's just give the others group write access. So we want it basically to look like this, right? So 6, 6, 6. Or let's say we wanted to add everybody. We wanted everybody to have read, write, and execute. That would be read, write is 6 plus the execute bit. So plus 1 is 7. So instead of 666, it would be 777. And that file is called hello. So the way this works is change the mode to 777 of this file. And in this case, we're looking at just a text file or something like that. So hit enter on that. Let's look at it with LSL. Yep, turned green. When you add execute to something, it turns green in the terminal. Doesn't really change what's going on with it, but now we can actually execute it. That green is meant to tell you, hey, you can run this. You might want to look inside of it before you do. All right, so read, write, X, read, write, X, read, write, X, right? Because 4, 2, and 1. 4, 6, and 7. You just add 4 to 2 to 1, and you get 7. And that's what these permissions are. 7, 7, 7. All right. So what if we wanted to do something else? Let's say we want the users and the group owners, or the user and the group owner, to have full read, write, execute access to it, but everybody else should get nothing. So how would we do that? So in this case, same thing, right? We said we wanted read, write, execute for the user. We wanted read, write, execute for the group, but we wanted nothing for everybody else. And then we do that. So it should stay green. Yep. But notice, everybody else, nothing. So unless you are Leo or in the Leo group, you get nothing. That's everybody else. So what if we wanted, let's take off the execute bit. This is not an executable file. We don't want to accidentally execute it. Even if we did, it would probably fail, whatever it is. So let's change that up a little bit. So let's just remove off the execute bit. So we have read, write, execute. We want to remove the execute bit, right? But we remembered 7 is all of the things minus the execute bit, which is 1, and that brings us down to 6. So 6 and 6, but we still don't want anybody else to have anything. The green goes away because it's no longer executable, and now it's read, write, nothing. But let's say I want this file to be super secure. I don't remember if I've added anybody to my groups, to my Leo group. So I just want to be super duper, I mean, we can check, right? But I just want to be super, super secure on this particular file. And yeah, I just don't want anybody to be able to see or touch this file besides me. So let's do that. Chmod, change mode. And I still want read, write, execute for myself. So 6. But group owners, I don't want them to have anything. And everybody else, I certainly don't want to have them have anything. So we'll look at hello now, or we'll select the hello file, and then we'll look at it. And so hello, coming over here, read, write. But Leo, why would you ever want to do that? There are sometimes on a Linux machine, you'll have something called private keys that will let you log into other Linux machines. Well, anything that supports SSH. Usually that's Linux machines. But without a password, or in conjunction with a password, you want a key. It's basically a file that contains like a 200, 300 character password, right? That file is not really reproducible unless you steal the file itself and then copy it. Then you want to keep that secret. You don't want anybody on the entire system to be able to look at that. The permissions like this kind of help with that, right? Only the owner can check that file out. That's the idea. Okay. So if you've been looking at this output and you've been saying, but Leo, all those directories have execute on them and they're blue, not green. What's up with that? Yeah, that is the execute bit on a directory. You can't run a directory, but you know what you can do to a directory is you can go inside of it. The X allows people to, in Windows terminology, would be to traverse. So what that means is I can CD into documents. So I can look into it. I can be in it. That's the idea. So execute for directories is common. You do want that. You don't want it for files because you might accidentally run the file. And if that file is a script and it has things on it, you're just going to do those things. So you want to try and avoid putting execute on a file, but you typically always want execute on a directory. Now, you may not. There are good reasons to not have execute in a directory. You don't want people milling around in there, but you still want them to have read so they can be able to, access things inside of it. Like I can do something like, something like mount dev SDA1 or something, right? Like I have a disk and I want to mount it, and so I can get at the files on it or something like that. I want to do that, but I don't necessarily need the execute permission on the dev directory to be able to get at that. If I know it exists, then I can mess with it. That's the idea inside of directories that don't have the execute bit. There are files in it. You just don't. You don't have the permission to go into that directory, but you can say, I know that file exists. That file, delete that file, or move that file, or whatever you want to happen onto it. You basically just, without the execute bit, you can't cd into that file, into that directory. I'm sorry. All right. So that's the basics. That really is it. I mean, if you've gotten that's I would say 80% of everything you need to know for this particular chapter or set of whatever. There are a couple of other little bits that are less common that you might want to know, or that you do want to know. There is right here. So let's say you're not good at math. Let's say you can't count to 7. Let's just say you don't want to count to 7. Or you want to target a specific part of the permission set. Right? And say user owners no longer need execute, or group owners no longer need execute, or others need nothing, or something like that. And you don't want to have to calculate, right? Because every time we had to do change mode, it was like, if I wanted to just change others, I still had to define, or in this case, 660 to hello, right? I had to know what the user owner's permissions were. I had to calculate that. I had to calculate what the group permissions were. I had to calculate that. And then, just to change the other group, just to change them, I had to know all the other permissions on the file. Well, let's just say I don't want to do that every single time. Well, you don't have to. There are symbolic modes that you can use, and it takes basic mathematical operators. That sounds scary. It's not. Plus, minus, and equals. You know those. Those are the ones that we use. So let's say on the same hello file, we wanted to ease up a little bit, and we wanted to add read-write back to groups. Or you know what? Let's just add read to groups, just to make this really simple. So group, G, add read to the same file. So instead of going 640 to get these permissions, right, because it already has read-write, I want to add 4 read to the groups and nothing to the others. To do that, we just say groups add read. And then you hit enter. Let's look. Ta-da. Now it has read. So I get a lot of students that breathe a sigh of relief right here, because we're like, oh my God, I'm gonna have to every single permission. I'm gonna have to figure it out every single time. Nope, you don't have to. You can do it like this. However, the octal mode is the base one. Understanding the octal modes, just like in IP addressing, right? Like understanding the IP address, where it comes from, and all that stuff, really makes it easy to figure out subnet masking and all that other stuff, right? There is kind of a subnet mask, kind of like something that's equal to subnet mask in permissions. We'll get to that at the very end. But that's the idea, right? You want to understand octal modes, but you don't need to use octal modes every single time you want to change a permission to something. You can use the symbolic stuff for that. But you can't forget how octal modes work, so we have to cover it. All right. So, and that works no matter how you want to slice this file, right? Let's say I want to others. Let's add something to others. chmod other add read hello. Let's look at it now. And there it is, right? We added read. And it works in the reverse as well. Like, whoops, I didn't mean to add read to others, so let's subtract read. And now it's gone. And same with groups, right? Like, I didn't mean to do that. get rid of that as well. And now it's gone. So you can do that with singular permissions. You can do that with write. You can do that with anything, any one of those permissions, RWX. So I've got a couple of examples over here, right? Subtracting read, write, execute from others. Making groups equal to RWX, or I'm sorry, RX, read and execute, and adding the execute bit to user. This is a very common one right here. You'll download a script off the internet. You'll need to make it executable, and this is how you do that. Just for the user, just for you, make it executable, and then on that particular file, right? So this one's pretty common. So these symbolic ones are easy to handle, easy to kind of remember. All you got to remember is user, group, other. Those are the three columns, and then you just got to know what RWX stand for: read, write, and execute. After that, it's basically users, add, execute, or user, remove, execute. Groups, remove everything, right? And to remove, you use subtract. To add, you use the plus. To make something specifically the way that you said, use equals. So fairly simple. Don't have to spend nearly as much time on that, but that's the idea. So in your lab, I don't care. I don't care if you use octal modes if you feel more comfortable with that, and I don't care if you use a symbolic modes. Does not matter to me so long as the permissions are what they are at the end, like what I'm asking for at the end. So whatever you feel more comfortable using, use that. Okay, so we've talked about changing this stuff in these columns. The last thing we got to talk about is changing stuff in these columns. Then I have a couple other tidbits to tell you. So, how do you do that? It's a ch command. It's just not change mode. It's change ownership. You can only change the ownership of the user that owns it or the group that owns it. So, how do you do that? Well, easy enough. There aren't many users on this machine, so I'm going to just swap between me and root. And to do anything with root at all, you have to use the sudo command or sudo command. So same command and everything, we just have to add sudo in front of it to do as a super user, to do as root. So we're going to change the ownership of, let's say, the hello file. Oh, I'm sorry. Change the ownership to root of the hello file. Let's look at it now. Ooh, different. Root now owns that file. Still in the Leo group, but I stripped off all the Leo permissions, all the group permissions here, so I have no permissions to this file anymore. I can still use sudo to make changes to it, but now, I mean, I can't, like, if I'd say cat, hello, nope, you get nothing. So, what do? Well, we can just dump it all over to root. So let me show you one other command, which is change group. So change ownership, change group. But I'll explain to you why I described change ownership as being able to change both. There's a way to do that. So change group only affects this column, ever. That's it. Change ownership can change both. So change group is kind of optional. You don't have to use it. You can use change ownership instead if you want. But let me show you how this works. So same exact way, actually. Change ownership to root on the hello file. This is what we did before. This is what we did up here. Now change group ownership to root on the hello file. Let's look at that. Look at that. Root and root. Cool. Now I want to change it back to Leo because I still want to own this file. So this will give me an the opportunity to show you an example of how to do changing ownership of both at the same time. So change ownership. I want Leo to own the file and Leo to group own the file. And the file is hello. So as an admin, change the ownership Leo as the user, Leo as the group of this file. And you can, depending on what you need, you can make these anything, right? So say the Betty group, it would be Leo : Betty. Or say you wanted Betty to own it, but Leo to be the group. So Betty : Leo. But in this case, I want Leo to do both. I want Leo as the user owner, Leo as the group owner, and we're talking about the hello file. So let's do that. Let's look at it, and everything's back to normal. Leo, Leo. Good stuff. All right. So doing directories is weird. So when you say change the ownership of a directory, a lot of times what you mean is like change all the stuff, like the directory and the things inside of it. Well, Linux is very, very, when you tell someone to do something and they do it exactly the way that you say, not what you intended, that. Linux is very much like that. So you have to be explicit a lot of times. So let me see if there's anything in documents. Nothing. Let me see. There wouldn't be anything in anything, really. How about this? Let's move new InMap, NoHup to documents. Okay, those files are gone now. Let's do LSL of documents. And what's inside of there? Perfect. Okay, let me show you what I mean by this. So I want to change permissions on the directory, the documents directory. So let's do that, right? So let's say, let's just remove. So it's got readx on the others. Let's just remove that out. I don't want anybody else to be able to go in there. Those are my secret files. Only the users and group owners of this directory can see that stuff. So let's do that. Change mod. Let's do it the symbolic way. No, it's not read write, it's read execute. So others want to remove read execute of documents. And if we take a look at that, it worked, right? They don't have any read or execute in there. But as I said before, right? So my intention was to hide all this stuff. And you would think that by changing the permissions on a directory, the stuff inside of that changed too. Right. That is the idea of inheritance. Windows does this by default. Linux does not. So to force inheritance, you have to do something else. But let me just prove the point. Let's do LSL of documents. And if you take a look, there's a couple of files in here that still have read, even though I said others remove read. So when you do that, when you do change mode to a directory, it only affects the directory, nothing inside of it. Only the directory. So let's say that we want it to work on the directory, right? We actually want, on the files, I'm sorry. We want it to actually affect the files inside as well. So I'll come back up to my file up here, and we'll need to say recursive. So R. This means that everything inside is also going to be effective. So recursive means to the thing, affect the thing that you're talking about, but also the things inside. That includes if there are directories inside, they are affected, and all the files. So let's say there are 8 levels deep of directories. They're all going to be affected. So it's all or nothing. So if we do that, LSL documents, and take a look. So it's different now. So we had read before, we don't have read now. But all I messed with was the directory. But this recursive said, and everything inside. So to read that, change modes of the thing I want and everything inside. And what I want you to do is remove from others, read and execute. And I'm talking about documents directory. And that worked. So directories have a little bit more consideration than regular files do, but that's it. So the recursivity of those things do make a difference. And we're going to play with that a little bit during the lab. Okay, did I hit everything? I think so. Symbolic modes, changing ownership, changing owner and group, and changing group. Cool. All right. So we have two more topics to talk about. One are the special bits, and the other is UMask. So we're almost there, I promise. So sticky bit, set group ID bit, set user ID bit. Those are the three special bits. Turns out there's an extra column over here that you can't see. It's only one, just like this one, just like directory and whatever. It's just like that one, but it's hidden. You don't actually see it. There's no special column for it. It just affects these permissions in wonky ways. What do I mean by that? Let me show you. So I want to let's play with the documents directory. And let's just set a sticky bit. So I'm in my home folder, by the way. I want to show you some examples of dealing with files that are not in the same directory as you. That comes up quite a bit. So I do want you to be able to see how to do things like a file is in a directory right below me, but I'm not in that directory. So how do I manage that file? So I want to show you how to do that. Anyway. So what I want to do in this particular instance is add the sticky bit. What is a sticky bit? Sticky bit is only the user owner can delete it. That's it. So if the group owner was Betty and Betty had write access to the file, but I do not want Betty to be able to delete it, right? I want Betty to be able to change it, add stuff to it, remove stuff from it, but I do not want her to be able to delete that file. I will add the sticky bit. How do you add a sticky bit? Same way as you add any other bit, except there's like I said, an extra column. So chmod, change mode, and the sticky bit, just like execute, read, and write had their own octal mode, sticky bit is worth 1. The set group ID bit is worth 2. Set user ID bit is worth 4. 4, 2, and 1 is 7. If you wanted to add all of these things, you would use 7 in this first column. Okay, so that'll make sense. Just one sec once I add the sticky bit. So I want to use octal modes in this case. I'll show you how to do both. I'll start with octal mode. Okay, so to add the sticky bit, 1. Then the normal permissions of that file. So let's play with, let's do InMap out, because that does have group ownership. And 7, oh no, I'm sorry, it's not 7, it's read write, so that's 6. Read write, so that's 6, and nothing else, so that's 1. So where did I get that from, right? Read write, 4 and 2 is 6, 4 and 2 is 6, nothing is 0. And that hidden column, sticky bit, that special bit, is right here. So, and then I said I wanted you to see stuff inside. Right, so where I'm at, documents is inside of here. So I can just reference it without any kind of slash or anything like that. So I can just say documents / InMap out. So inside of documents, there's a file called InMap out. That's the one I want you to be dealing with. All right, so change mode. I don't want the permissions to change. I just want to add the sticky bit to the InMap.out file. So now only I, Leo, the user, can delete that file. It makes that file sticky. Can't go anywhere unless I do it. So let's LSL documents and let's see it. You see something funky about that? Yeah. There's a T. No one else but me can delete that file. So there's a T there. So it can be a big T or a little t. It doesn't matter. As long as it's a T right in that spot, that means a sticky bit. So a big T means there's no execute bit behind there, right? Because if you notice, we didn't add extra spots or anything, right? So it's covering up the other execute spot. So if there was no X there, behind there, it's a big T. If there is an X behind there, it's a little t. Let me show you what I mean. let me just add chmod other plus execute. I added that bit now. And notice, all right, it's executable. And the T is little now. So it doesn't matter. If there's a T there, big or little, you know the sticky bit is applied. If it's big, there's no execute behind there. If it's little, there is an execute behind there. So I'm going to undo that. And by the way, using the up key will give you commands that you've already run, especially when you just need to change one thing. And then run that bad boy again. Cool. Big T again. Keep that in mind. All right. So again, now only the user owner can delete that file. Now, let's say we want to do that same thing to the new InMap out file. That's in that same directory, but we want to use the symbolic modes to do that with. So same deal, chmod plus T. That's it. T for sticky bit, I guess. That one I never figured out why they wanted the letter T for that, but whatever. New InMap out. Documents, and notice now it's got the T. Right? So now those two files are protected essentially. So I'll leave those that way. We'll tinker with them if we have to in a little bit. All right. So let's focus on the set GID bit. So the set group ID bit. This goes on a directory, not on a file. Because what it means is anytime you create something inside of that directory that you have this bit turned on for, the group ownership of the directory will mirror any file that you create. So if you create a file, actually, let me just show you. So let's say, okay, for instance, let's look at documents. Leo, right? So if you created something inside of documents, it would be created with Leo as the user and group ownership. So let's do so. File 1. Oh, actually, you know what? Let's touch documents, file 1. And that just creates a file. Usually it's used to update timestamps, but we're going to abuse it a little bit. And right, there you go. Read, write, read. Leo. All right. Well, now let's change the set GID bit on the documents directory. So change mode. Let's do 2. What were the permissions there? Read, write X, read, write. Or I'm sorry, read, write X, read X. So read, write X is 7. Read X is 4 plus 1 equals 5. And then there was nothing on the other one. And then that's documents. Right? So 7 is read, write X. 5 is read X. 0 is nothing. 2 represents the sticky bit. I'm sorry, not the sticky bit. This is set group ID bit. Now let's look at it. All right. Look at that. S. So read, write is where the execute should be, just like it worked over here. Right here, actually, yeah. Right here. So if there was a big S, there would be no execute. But because there's a little s, we know there's an execute back behind there. So what does that do? Well, the way that it's currently configured, nothing. But let's do this. Let's change own to root. So remember how I did this before, where I had Leo, and that would be user and then group? If you don't specify to the left of the colon, it just changes the group. But that's not going to work because I don't have sudo, so let's do that. Now let's look at it again. Notice, root now group owns this directory. All right, so now let's touch file 2. And then let's look inside of documents and see what happened. There you go. So the first file I created when I group owned and owned it just worked. Now that I set the set GID or set group ID bit and root group owns this directory, any file I create inside of it also is group owned by whoever group owns the directory. Okay, so what does this mean? Why would you use this? This is a case where, let's say you had a shared folder, and instead of using the root group, you use the accounting group. That way, you could have an owner as maybe root or the name of the administrator. Let's call it Danny. So Danny owned the directory. Maybe he's the manager of the accountants or something like that. And then you want it to be group owned by the accountants. So accounting is what would go right here. And now anything that gets created inside of that directory is group owned by accountants. So you can give them read write. So a lot of times what you'll see is not only do you give the SGID bit on a directory, you set the sticky bit on every file inside. Why would you want to do this? Right? Danny owns the directory and all the files inside. The accountants group own everything inside, but you don't want the accountants to be able to delete things. Only Danny can do that. So the sticky bit means only Danny can do that. The SGID bit means that once you configure a directory like this, right? So say it's Danny and accountants. Danny and the accountants will be on every single file that you create inside. So that is important to know, especially when you have shared directories. That's the whole point of the SGID bit. All right. So you can do it like this as well, G plus S. Do that on a directory. In this case, it's in the scripts directory. So add this, add the SGID bit. And it's G because the set group ID bit affects groups, right? It's in the group column. So group plus S. All right. Now, last thing, the set user ID bit. This one is one you won't see happen very often because it's a very, very thin slice of what happens. Yeah. The idea is that if you add this to a file, no matter who tries to run it, it's run as the owner of that file. Okay, so let's say in my home folder, right, I create the, oh yeah, I've got the basic install shell script in here. This is a good example. I want to allow anybody to be able to run it. Doesn't matter who. I don't care, right? But notice, others cannot. Actually, you know what? Let's do it. So let me remove that off. So change mode, other -x, basic install, right? I don't want others to be able to execute it, right? That's just the basic permission set. But in reality, I do. The idea is that you can have the least amount of permissions on it, so people can't change it, but you also want them to be able to run it or something like this. A lot of times what you do is this is added to a script or something. So what you would have is change mode for, and then the permissions of the file. In this case, it's RWX, which is 7, RWX, which is 7, and R, which is 4, so 774. And then the name of the file. Let's look at it. Right. It's highlighted in red because danger, Will Robinson. If root owned this file, whatever's inside of that file would be run as root. And that is a scary prospect. Because if you or the group owner, like in this case, so say the accountants owned this file or whatever, they would be able to change the contents of this file and then run it as root without root permissions. Right? So if it said root and then accounting, this would be a dangerous situation. This is the kind of stuff that green administrators will do without thinking fully through the consequences of doing something like that, right? Like, I don't care. I just want them to be able to run this file. So I'm just going to set UID, set the UID bit on this, whatever, give it to root. That way, they don't have to elevate, or I don't even have to care what group they're in. If they're in the sudo group, so they can do, elevated things, have elevated privileges. I don't care, whatever. Just let root own it, put the set UID bit on it, and then, let anybody have at it. That is extremely dangerous. It solves the problem of being able to run the file, right? Execute the file. But it's a horrible way to actually solve that problem. So this is in the same level as I said before, right? 777. You'll never see it in use, maybe just in testing. Yeah. This is in the same, set user ID bit is in the same category as that if root owns it. And anybody else can change it. Doesn't matter who that anybody else is. Yeah. So, So what you would really want in a case like that is if you do have permissions like this, you would just want root to own it and group own it. And let nobody else do anything but read on it. And then you can set the user ID bit. Right. Okay. Well, I had a question before, like, well, why wouldn't you just give the others execute on the file if you wanted them to be able to execute it? Well, because setting the user ID bit allows users to run it as root, so they don't need if something in the script does something that needs elevated permissions, if you just give others the execute bit, it will fail. They don't have permissions to do that. So setting the user ID bit allows someone that doesn't have permission to run as root on that particular script so that they don't have to elevate permissions or anything like that. All right. And yes, if you were thinking it, you can add all 4 of these things to something. You don't typically do that. Typically, if you wanted to do a directory, have the sticky bit, blah, 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 whatever, you typically don't add them, but you can. You could just put 7 in that first column and affect one thing with everything, right? That's set UID bit, set group ID bit, and the sticky bit. You could. You would want that on a directory, right? The sticky bit and the set group ID bit. You can do that, and that would just be 3, right? Because 1 and 2, add that together is 3. You could do that to a directory if you wanted. So it'd be 3775 or 3770 or 3750, whatever the permissions are on it, right? But it would start with a 3, or you could just do them singularly. It's easier to do it like this. Just run that and then run that, and that will add the sticky bit, add the set GID bit. Typically, this only really happens on files. So, one last idea that I need to leave y'all with, and that's UMask. So, if you've noticed, there have been permissions on every file that I've created, right? Every single file that I've created has had some base set of permissions. Well, how does the system know what the base permission should be? UMask. So, UMask, just type it in, and it'll tell you what the base permissions for every single file is going to be. Ding, ding, right there. So, what does that mean? Because that looks like nothing that we've seen before. Okay, well, let's look at that set of permissions real quick. Let's come down here. And then just remember, there are 3 columns, 3 main columns, and then there's that 4th extra column that we've been playing with. Sticky bit, set GID bit, set UID bit, right? So, the set UID bit, set GID bit, that special column is this one. Then it's user, group, other. Okay, right, but that still doesn't make sense because these numbers don't match up. Okay, so just keep that in mind, right? I'm filling up those columns. Here's the idea, and this works actually almost exactly like subnetting works. So if you understand subnetting, if you have a good grasp on that, this is the same idea, though we're not dealing with binary numbers, I guess. But, all right, so here's the deal. There are the 4 columns, right? 4 columns. Here are the 4 columns, but they're all filled up. So let's put in the UMask now. And then it just becomes a subtraction problem. So 7 minus 0, 7. 7 minus 0, 7. 7 minus 0, 7. And then 7 minus 2 is 5. So here's the deal. This one is special. This one always ends up being 0. It is just special that way. You have to remember it. So that one always gets set to 0. Just keep that in mind. I know it's confusing. It doesn't directly make it just a subtraction problem. I understand. But just keep that in mind. You will never have a set sticky bit. You will never have a set GUID bit. You'll never have a set UID bit on by default. So no matter what this comes out to, this first one will always be 0. But as I said, the rest of it's just a subtraction problem. So 7, 7, 5. Now that looks like something that we've seen before. 7 is read, write, execute. 7 is read, write, execute. 5 is read, execute. So if I were to create a directory, test_dir, what would its permissions be? So let's look at test_dir. Read, write, execute. Read, write, execute. Read, execute. Right? Exactly what we had right here. So UMask is the inverse of the permissions that you are going to have on any new directory or any new file. So 0002, again, that first 0, you can just ignore it. Ignore it, ignore it, ignore it. It will always be 0. And then 7 minus 0, 7 minus 0, 7 minus 2. 7, 7, 5. And that tracks. Tester, 7, 7, 5. That's how UMask works. So let's take this, for instance. The UMask I have in the notes, 0027. Okay, again, on the left, that first 7. I don't care what subtraction says, neither does Linux. 0. It will always be 0. Now let's update. 7 minus 0, still 7. 7 minus 2, wait a minute. Change that to a 5. 7 minus 7, 0. Okay, so you see that number? That number is special. Let's change the UMask. How do you do that? Just type it in. So we want permissions like this. Our UMask is this. Let's see if that actually tracks. 0027. Right? So that's our current UMask. And you can double check it by typing in UMask. Right? So we set it to 0027. It was 0002. Changed it, UMask 0027. And we ask, hey, UMask, what's up? 0027? Right. Now let's verify. If we create a directory, do we get those permissions? Let's find out. Test_dir2, because I'm so creative. Let's see. Read, write, X, that's 7. Read X, that's 5. Nothing, that's 0. 7, 5, 0. Ta-da! It does track. It does work. Now, there's one more special rule that you have to know, and then you fully understand UMask. And that is files, regular files, never, ever, by default, get execute. Ever. There's no like, sometimes it does. No, never does it ever get execute. It is a safety catch. When you create a file, it's not executable by default, so you don't, like me, sillily run it just out of curiosity. I wonder what happens, right? It's a safety catch. You have to go and add the execute bit yourself. So what does that mean? That means that, right, 7 includes the execute bit, right? Read, write, execute. But because it's a file, that X gets stripped out. So the UMask does affect files. But it's basically the same permissions you would get with directories minus the X's. Wherever the X's are, doesn't matter. If they show up in the other group, doesn't matter. Show up in the group, or the group, yeah. Show up in the group column or in the user owner, that's the word I was looking for, show up in the group owner column, user owner column. Doesn't matter. The X gets stripped out if it's a file. If it's a directory, it gets the X. If it's a file, it does not get the X. Because remember what I said about directories. Execute. Directories need execute so you can change directory into them. Files do not need execute because sometimes they can contain malicious code and you don't want execute on it by default. You want to have to take that extra step, that are you sure, and that are you sure is adding the execute bit. Okay, so what does this mean to you? When you create a directory with this UMask, you get RWX RX, right? With our current UMask, which is 0027, right? So RWX RX. So if I were to create a file, what permissions would I get? Same thing, but no X's. No X's ever. So let's do it. So test file. Now let's see. So if I am correct, then the permissions will be the same minus X. So RWX, well, no X, so it would just be RW. And then RX, well, no X, so just R, and then nothing else, right? So it should be RW, no X, R, no X, and then nothing. Let's find out. There it is. RW, no X, R, no X. That's the idea. And I inadvertently showed you something that's very important in Linux, and that is big T and little t, totally different. So you can have two files named test file if you want, but if they have different capitalization, they are separate files to Linux. Not so in Windows. That's confusing to folks that are mostly Windows. This can happen in Linux. But anyway, what I wanted you to get was directories get the X if the UMask says they should. Files never get the get the X, never get the X, even if UMask says they should. That is extremely important to understand. So you want to deal with UMask. Anytime you're changing UMask up, because it affects anything you create, you always want to go with how would this affect directories? All right, because directories typically, unless you have a good reason not to, will always have the X. So you want to tinker with UMask, assuming that whatever you're going to be doing is getting the X, right? Because you want to concentrate on the directories. Those are the big things. But files never get the X. So even if UMask says, oh yeah, that permission should be 7, doesn't matter. The X gets stripped off when you create that file. So it's effectively 6, but you don't have to think about it that way. Just think about it as 7, and out of an abundance of caution, we always strip out the execute from a file to save you from yourself. That's really the idea behind why UMask behaves that way. So, we made it. That's it. So, set your UMask that way. And it's basically subtracting permissions. That's how that works. Just like subnet mask, kind of in the inverse, tells you what you can and cannot use. UMask tells you what permissions you do and do not get. That's the idea behind it. So, the same reason subnet mask is a thing is the same reason UMask is a thing. Tells you what you can get rid of. All right. Woo! We made it. We made it. Yeah, this is barely 2 pages of stuff, but there was a lot of talking involved because there's a lot of explanation that goes behind these permissions and why things are the way that they are. So if you have any questions about this, please, please, please get in touch with me. I'm more than happy to help you out with this. The quiz, bunch of questions about, what is this UMask? If I wanted these permissions, what would the UMask be? Or, would this particular user be able to do this particular thing to a particular file or something like that? So just a lot of practical questions about that stuff. And then the lab is a bunch of practical things. I don't care what you use because permissions are ubiquitous. It doesn't matter if you use CentOS, Ubuntu, or OpenSUSE. We're kind of at the point now in the class where I don't really care what you use. There will be some times when I'm like, this only works in OpenSUSE, so you got to do it in OpenSUSE. But I mean, by and large, the majority of the stuff is, I don't really care. Do it however you want, or do it in whatever VM you want. So this is basically creating, a storage directory, creating an accounting share, looking at the permissions. So pretty much what we're doing here is I'm asking you to change permissions on a particular file in a particular way. So like in this case, I want the permissions to be that. Right? So there's really a D there, but what I really want you to do is just focus on the permissions. So focus on the permissions there. And I guess I'll just go in and update that as a D. But the idea there is read, write, X, read, write, X. That's what I want on those two directories. And then you'll run LSL of storage, which is where those directories are, and then take a screenshot of that. And I'm just verifying that the permissions look exactly like that. If they don't, well, yeah, there's some points going away. But that's the idea. Every time you make some changes, I'm going to ask you to take a screenshot of pretty much an LSL. If you look at this, every single submission is an LSL, because all I want is to see the permissions that you've got on those particular things. And so we'll be dealing with, like we haven't talked about adding users to a group, so I'm giving you that command, how to deal with that. But we're dealing with sticky bit, SGID bit, changing group ownerships, and changing ownerships. So all the stuff that I've talked about today, that's how this lab's going to go. All right. But that's it. That's the end of it. Get all that stuff done this week. Please ask me if you have any questions. And we're about done.